So I've shown the forces with a little bit of effort here. Let's see the forces once again acting on this block 1 as viewed from x dash y dash frame. There's an mg cos alpha in the minus y dash direction, and in the plus y dash direction we have got the normal force of magnitude n and the sine component of the pseudo force Fp sine alpha, where we have got the force of mg sine alpha and Fp cos alpha, both in the plus x dash direction. Here I want to remind you that the pseudo force Fp is given in magnitude by the mass of block 1 and acceleration of the wedge, that is A2 here. The direction of the pseudo force, of course, is to the left, that is opposite to this acceleration direction A2. So I'll just make use of that here. As a quick reminder of what we said some time back, I have told you that the pseudo force acting on the block, that is Fp, I denote it by, vectorially it is given by minus mass of the block multiplied by the acceleration vector of the wedge frame from which the block is being observed, right? So here I could definitely write here, I'm just incorporating that notation here as well. This is minus signifying direction of this force, pseudo force, is opposite to the acceleration of the wedge from where this block is being observed. X dash y dash frame is attached to the wedge. So this is nothing but minus m is the mass of the block, into the acceleration of the wedge frame from where the block is being observed. But I want to say here the numerical value, that is the magnitude of pseudo force, is of course given by mass of the block into the acceleration of the wedge. Don't make a mistake here. The minus sign is sitting vectorially because to denote the direction of the pseudo force is opposite to the direction of the wedge from which the block is being observed. Minus sign is because of that. But if you go for magnitude of the pseudo force, that is simply given by the mass of the block multiplied by the wedge frame from which the block is being observed. So I could write down, and I'm sure you understand it fully, that Fp sine alpha actually is nothing but ma2 sine alpha in magnitude, right? Similarly, Fp cos alpha in magnitude is equal to simply ma2 cos alpha. Here I just emphasize this again and again because students have some wrong conception. This minus they cannot digest properly. This minus was seated here to denote pseudo force and the acceleration of the frame. They are opposite direction, but in magnitude, the magnitude is definitely given by the mass of the block multiplied by the magnitude of acceleration of the wedge frame from which the block was observed. So Fp sin alpha is same as ma2 sin alpha, and Fp cos alpha is same as ma2 cos alpha. Now with this knowledge, we can just proceed to write down the equations of motion of the block 1 as viewed from non-inertial frame. So let me write that. We're going to just write down now equations of motion of block 1. And that again, we're writing in the non-inertial frame. X dash y dash, as you can see from the figure. Okay, so let's proceed for that and write down the equations here. First of all, equation of x motion. So I'm just writing it, sigma fx dash, that is for the x motion. Let us collect the forces acting on this block in the x dash direction. As you can see, this is coming out to be mg sine alpha. This is the component of the gravity force acting down the incline, and here is the component of the pseudo force whose magnitude is m into a2 into cos alpha. So the two forces is acting in the x dash direction, both positive direction. So we write down that mg sine alpha plus m into a2 cos alpha. This is of course the cos component of the pseudo force acting on the block. That is the net force in the x direction. That is equal to mass into acceleration. Now here the mass of the block is m. And what about acceleration? Let me introduce a small arrow here. This is in red color to distinguish an acceleration arrow. And you know that as viewed from the wedge, this block appears to slide down the inclined face parallel to this inclined face line. So this is the acceleration. Look at the symbol carefully. This is the acceleration of block 1 with respect to the wedge 2. This is the new symbol for you, and just see it carefully. I've taken a previous session here on relative velocity and acceleration, and I told you there, if the notation is like this is read as acceleration of block 1 with respect to the wedge 2. And that is exactly what we are doing here, because since the x dash y dash frame is attached to the wedge, that's why we can see the block's acceleration down the inclined face, that is the x dash axis, is nothing but the acceleration relative of the block 1 with respect to wedge 2. So the symbol is somewhat different. It's not a1, it's simply a12, acceleration of block 1 with respect to the wedge 2. So here be careful about this notation. It is quite meaningful. So we write here, this is coming out to be m into a12, and that's my equation number 3, and that is equation of x motion for the block as viewed with respect to the wedge. Next we go forwards and write down the equation of y dash motion of the block with respect to the wedge frame. Let's look at the forces here. We have got a force of normal force. The minus sign is sitting because it is the reaction of the force N shown earlier on the FBD of the wedge. We have shown when the force is applied by the block 1 onto the wedge, we call this force as N, and minus N being reaction of that, equal and opposite, I have put the minus sign, but you understand that both N and minus N have the same magnitude, that is simply N in scalar notation. So that's in the positive y dash direction. The other force in positive y dash direction is the sine component of the pseudo force, that is ma2 sine alpha, while the cos component of gravity force mg cos alpha is acting in the minus y dash direction. So we could write down that the equation of y motion is coming out to be normal force is positive in the y dash direction, plus we have got ma2 sine alpha also in y dash direction, and we have got mg cos alpha in the minus y dash direction. And as viewed from this wedge frame, the block slides down the inclined face, so there is no motion away from this inclined face. That means the block does not leave the inclined face. It has got no motion in either y dash or minus y dash direction, because the block remains in contact with the inclined face all the time. So all the motion taking place in the x dash direction, and there is no motion taking place perpendicular to this inclined face. So you could write down in my y dash direction, acceleration of the block is simply 0. So that's my equation number 4. So let's look at these equations once again very briefly and quickly. For the x dash motion, we have got the mg sine alpha plus ma2 cos alpha giving its acceleration a12 with respect to the wedge. The symbol, I have insisted that you be careful about it. And in the y dash direction, that's the direction perpendicular to the wedge, there is no motion of the block, hence all the forces N plus ma2 sine alpha minus mg cos alpha must giving you 0, because y dash motion is completely absent. These are the 4 equations of motion of the wedge 2 and the block 1, but keep always in mind in this lecture today, we are writing the equations of motion of wedge in the ground frame, while writing down the equations of motion of the block in the wedge frame. That's a frame attached to the wedge itself, and the wedge being itself in accelerated motion to the right. Now, since the page has become quite congested, I shall prefer to go to a fresh page, but before going there, let me collect all the important equations obtained so far They are equations 1 and 2. They are the equations of motion of the wedge as viewed in the ground frame. And then equations 3 and 4, equations of motion of the block as viewed in the wedge frame. We shall take these equations, go to the fresh page, draw the main figure once again and solve them to get all the unknown quantities. Remember, we don't require a constraint equation here because we are solving the problem in the non-inertial frame of the wedge with the help of pseudo force.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.